This is the actual velocity time graph of my Formula One lap on one of my favourite parts of the track. So we can see from the video and from the graph that the car started off going around the corner at a constant velocity of 40 meters per second, which is 90 miles per hour. Then the car's velocity increased, which meant it was accelerating until it reached a speed of 75 meters per second, which is 170 miles per hour. Then the car's velocity decreased, which means the car slowed down. And any time that an object's velocity decreases, or when an object slows down, we call it decelerating. So in this section of the graph, we can say that the car is decelerating. Then the car travelled at a constant velocity of 20 meters per second. Now in this question, we need to calculate the deceleration of the Formula One car, which is this part of the graph here, where the graph goes down. Now remember, the gradient of a velocity time graph is equal to the acceleration. So to calculate the deceleration of the Formula One car, which is this section of the graph here, we need to work out the gradient of this section of the graph. Now remember, we call the gradient m, and to calculate the gradient we need to do the op distance divided by the along distance. And some schools and students call this the rise divided by the run. So to work out the op distance and the along distance, we need to choose 2 points along this line, and then we need to draw a triangle between these 2 points. Now you can choose any 2 points along this line, but I think that the best 2 points to choose are the points at the beginning and at the end of the line. So I'm going to draw a triangle between these 2 points. So I take my ruler and I draw a triangle between these 2 points. And now we need to work out the op distance and the along distance of this triangle. And to do that, we need to read off some values from the graph. Now remember, to read off values from the graph, we always need to draw a dotted line on our graph using a pen and a ruler. So I go to the start of this line here and I use my ruler to draw a dotted line across until I get to the y-axis. And I can see that this value here is 75. And then I use my ruler and I draw a dotted line from this point vertically down until I get to the x-axis. And I can see that this time here is 9 seconds. Then I do the same to the end point of this line. So I draw a dotted line from the end point of this line horizontally across until I get to the y-axis, and vertically down until I get to the x-axis. I can now really easily work out the op distance of the triangle, because the triangle started off here at 20 and it finishes here at 75. So this distance of the triangle is actually 55. But hopefully you've noticed that this is not an op distance, because the triangle actually starts here and it finishes here. So if the triangle started off here, the triangle had to go down by 55 to get to the end of the line here. So instead of saying 55, we need to say minus 55, because the triangle went down by 55. So the op distance is actually a down distance. So we say that this is minus 55 and we're dividing it by the along distance. Now the triangle starts off here at 9 and it finishes here at 11, which means that the along distance was 2. So we have minus 55 divided by 2, which is minus 27.5. This means that the gradient of the line, which is the gradient of this part of the graph, is minus 27.5. Now remember, the gradient of a velocity time graph is equal to the acceleration. So if the gradient is minus 27.5, that means that the acceleration is also minus 27.5. Finally, we need to put the units of acceleration on the end of this answer. And remember, acceleration is measured in meters per second squared. Now, some students get confused with this answer because I've called my answer an acceleration. And actually, we were asked to find the deceleration of the Formula One car. Well, any time that you have a negative acceleration, that means that the object is slowing down or decelerating. So a negative acceleration is a deceleration. So saying that the acceleration is minus 27.5 meters per second squared is exactly the same as saying that the car is decelerating.